In this lesson, you'll learn about OIC lookups, which can be used for many use cases to include assisting with data transformations. Different applications sometimes store the same information by using different data values, which makes mapping data between them a greater challenge. A lookup associates values used by one application for a specific field to the values used by other applications for the same field. This provides the capability to map values across vocabularies or systems. For example, you can create a lookup for currency codes, organization or product identifiers, or, as in this example, country codes. These lookups will be based on static definitions where the values are preloaded at design time. Then later, those values can be retrieved at runtime within an integrations map action. Now, under the covers, the lookup is loaded into internal memory, much like a read-only database table. To retrieve the data, you'll use a special OIC function within the mapping canvas to provide the appropriate value to the target data element. To create a lookup for your project, you click the Add icon in the Lookups pane, choose to create, then provide a meaningful name. Now, once you click the Create button, you'll be on the Lookups Edit page. As shown here, when choosing domain names, there are logically two types of lookups: application-specific and those that serve as a more generic list of values. Now, for application-specific use cases, for the domain name columns, you specify adapter types, such as, in this example, logically. This type of lookup is intended for integrations that need to map between two of these applications. Or you can simply use generic names for the data columns, as shown in this example, which is often the case when the lookup is likely to be used in a wider variety of integration mapping use cases. Now, to add columns, you click this plus icon to the right, and to add more rows, you click the icon at the bottom of the page. Even though the values are static, a lookup can still be updated even after integrations that are using it have been activated, which means you can edit when required, such as adding another row of data. Once saved, there is no need to reactivate any integrations since it will be reloaded into memory within a couple of minutes. You can also export the lookup to other OIC environments or projects as a CSV file. However, this export option can also be used to update the lookup outside of OIC. Here is my example exported CSV file. As you can see, it only has the 3 countries listed. Now, I update the spreadsheet to add a whole lot more, then save the file. Next, I'll need to click here to add the lookup, but this time I choose to import a CSV file. At this point, I locate the updated CSV file, and then when I click the Import button, OIC recognizes that this lookup already exists, prompting me to replace the country codes lookup that is already in memory. And once that is done, I get a confirmation banner that it has been imported and replaced. So now to confirm, I can open the lookup where I can see that there are now 249 items. To configure access to a lookup in the mapping canvas, you'll find the lookup value function within the Integration Cloud area, where you can view the embedded help info on this function. However, when you drag and drop the function icon onto a target element node, as in this example, it launches this 4-step map lookup value wizard to help build the expression. First, you will select the appropriate lookup. In this case, I've highlighted that country codes lookup. Then click the right navigation arrow. Next, you select the source, where you indicate which type of data value will be coming from the source. In this case, the source is providing an alpha 2 country code. Then you select the value that will be extracted from the lookup to be mapped to the target node. In this case, the target requires an alpha 3 country code. You then click to advance to the next page. Optionally, you can provide a default value to be mapped to the target node element if a source match is not found. However, while we could provide a default country code, in this case I chose to leave it blank. Now we click the right arrow to advance to the summary page, where we can review the 5 parameter values added to the function, one of which serves as a placeholder because that source value parameter will require editing in the expression editor. We exit the map lookup wizard by clicking the Done button, which will show the function icon mapped to the target element, as shown here, along with the function shown down in the expression editor. Now we need to replace that text for the third parameter with the source value. In this case, it is the country ISO code from that source data structure. And when that is completed and saved, the expression editor displays the source XPath expression in the third parameter, and the visual mapper shows the line as an input to the function. Well, once you've completed and saved your integration, you can navigate over to the lookup pane to view your lookup. Notice that it shows it as being used by one integration. And when you click that link, it opens this pane to show the list of integrations that are using this lookup, even those that are not currently activated, as in this example. In addition to simple data transformations, there are other use cases to consider for OIC lookups. Lookups can be used to enrich incoming data with additional information from reference tables. For example, you might have a lookup table containing product codes and corresponding product names. When processing sales data, you can use lookups to retrieve the product names based on the product codes in the incoming data. Lookups can help route messages to different endpoints or apply filters based on specific criteria. For example, you might use lookups to determine the destination system for an incoming order based on the customer's location or order type. Lookups can be used to validate incoming data against predefined criteria and handle errors accordingly. For instance, you could use lookups to check if a provided customer ID has the correct format before processing an order. Lookups can be used to cache frequently accessed data to improve performance and reduce the load on back-end systems. And this is particularly beneficial when dealing with large static data sets or systems with limited resources. And finally, consider using lookups to store certain configuration settings that will change. This allows you to update configurations without modifying your integration flows. For example, you can use lookups to store certain API endpoints or credentials or connection parameters. So to wrap up, while lookups use preloaded design time values, you can update values when needed, and since they are loaded into memory, they provide much quicker performance as compared to making a database query. And of course, you'll leverage the lookup value function wizard in the mapping canvas when you need to access a value to map to a target node element. That's it for this lesson. Thanks for watching. Welcome now to Module 5, using integration actions. With over 20 actions available to integration designers, this module starts with an action overview lesson, then teaches you about the usage and configuration of many of those specific actions, facilitating the logic within your integration flows. Other actions not covered here will be discussed later in modules such as file processing and error handling. And once you complete these videos, don't forget to take the Module 5 skill check. Keep going strong. Welcome. In this lesson, I'll provide an overview regarding the use of actions in an integration flow. As part of integration design, in addition to adding and configuring outbound invokes to access external services, you'll need to add and configure other actions to perform various activities to complete the logic of your integration flow implementation. For example, map actions. To add an action, you have a couple of methods. One is to click the Actions icon on the right side of the design canvas, then locate and drag the icon of the action you want to use to the appropriate location in your flow. The other is to open the inline menu at that appropriate flow location, then locate and select the desired action. Each action, once selected, triggers an edit pane that pops out from the right side of the design canvas where you can configure as needed to include dynamic data values available from input sources or xQuery functions. However, in some cases, such as the stage file action, a unique workflow wizard will walk you through various pages to expose the edit options you'll use to configure the desired logic or data mapping assignments appropriate for the use case. To expose the pane for accessing input data sources and functions, you simply click the ellipse icon as shown here. So now let's quickly look at the actions you have to choose from. While the inline menu only displays actions that are valid for use at that particular location in your flow, you'll see that the action pane exposed on the right side of the design canvas actually lists all the integration actions, but disables the icons of those that are not valid for your specific type of integration. For example, the stop action can't be used in an application integration that uses a trigger configured with a synchronous request-response message exchange pattern. As you can see, the action icons are organized by categories. End action options will depend on the type of integration you have. For example, a callback action is only valid for delayed response integrations. Call actions provide functionality to invoke other integrations or custom JavaScript functions available within the same OIC instance. And within your OCI tenancy, calling a stateless function or accessing content in object storage buckets. Logic actions include while and for each looping constructs, a scope container used to organize other actions, a switch action for defining conditional branching logic, and the parallel action, which allows you to process other actions in parallel on different branches. Within your integration flow, you can explicitly throw a new fault or rethrow a fault that was caught within a fault handler. And all others are displayed at the top, generically categorized simply as actions. These include notifications for sending emails, stage file for creating or managing file contents, as well as several others. But don't worry, we'll take a closer look at all of these integration actions in other lessons or demos. To wrap up, most actions can be used in your integration flow regardless of which option you use, using an event or schedule pattern or in an application integration once you've defined the trigger connection. This concludes this overview lesson. Thanks for watching. Welcome. In this lesson, we'll look at using a data stitch action to support certain data manipulation use cases in an integration flow. You can incrementally build a message payload from one or more existing payloads with the data stitch action. While it supports both scalar and complex data types, complex data types are not limited to message payloads. You can work with arrays, partial and full message payloads, or any global variable. This action provides a configure stitch panel that enables you to assign, append, and remove data values or elements as needed. The assign operation places the selected value or element or attribute into the target element, overriding any existing data in the target. For example, say you want to change the current address in an existing purchase order. The stitch action enables you to change the address. You can either map fields individually or copy the entire address object itself. The append operation adds data at the end of a repeating unbounded target element or after a selected element or value. For example, say you have an existing purchase order payload containing 5 lines of items and you want to add a 6th line. The stitch action enables you to append another item to the existing array in the purchase order. The remove operation completely eliminates the target element or attribute from the variable. For example, say you have an existing purchase order payload and want to remove the price to enable the endpoint application to calculate a new price. Incidentally, for repeating unbounded elements, all instances are removed unless a specific array instance is selected by index or predicates. Of course, you don't need additional data stitch actions for each operation. You can instead define multiple assignments or operations on variables and child elements of variables by simply adding them, then configuring their values in one data stitch action. You can also define the sequence of variables to update. For example, if you want to copy an address and then override a child element such as a street, just place those statements in the correct order of execution. To avoid any confusion you might have had as to which use cases warrant leveraging this action, there are 2 other data-related actions that have some overlapping capabilities with DataStitch. So, as compared to the assign action, since it is limited to only scalar-type variables, complex data objects or full payloads, of course, are not supported. For the mapper, it is designed to only build a full message payload specific to a subsequent invoke connection or other action requiring a message payload. If you attempt to map into an existing message, a full replacement of that payload occurs. The data stitch action, on the other hand, can be used for both a partial or full assignment of data to a message payload. So while there are many use cases for the data stitch action, I'll show you 2 common examples. The first scenario involves making data available outside of a scope container. You see, a common practice, of course, is to invoke service connections within a scope so that you can take advantage of fault handling and mitigation logic specific to that service invocation. The problem is that the data in the message payload response from service A, as in this example, won't be available outside of that scope. So the solution is to copy that message payload to a complex type global variable, which can then be accessed elsewhere in the integration to include anywhere in any other scope container. Now, the assign action won't work since it is limited to only scalar variables, but the data stitch action can copy the full message payload easily. The second scenario involves building a message payload that perhaps aggregates multiple data items. Suppose you're invoking a fine-grained service several times within a for each loop. Then for each response, you can use the data stitch action to append that data to a complex data type global variable at the array as an array of items. When a loop is complete, you can then use that variable to provide a full message payload response containing all the data items as the reply. Be sure to watch the next video, which demonstrates the implementation of both of those common data stitch use cases. That's it for this lesson. Thanks for watching. Welcome. In this video, I'll demonstrate how to leverage the data stitch action in an integration flow. I'll actually break this demonstration into two parts. The first part involves the use of assign operations. The second also uses the append operation to add multiple items. So you may recall this use case from the data stitch action lesson where we need to make a message payload available outside the scope in which it was retrieved. So in this example implementation, I have a simple trigger defined, a REST trigger, if we can open it up and take a look. It uses a get method to simply send in the ID of an item. And then the expectation is at the end of the integration, we will respond with a JSON object that includes the item ID that we've submitted, who it was created by, the date, and the owner information in this syntax format. So that means the response going back expects a mapping of that data. Well, the data is going to come internally from calling an external API, and we're going to achieve this by getting the data from the response of this get status invocation to the service by assigning the data that is returned within the stitch action. First, though, we need a global variable to paste that to make it available outside of the mapper. And if I can open up the mapper, I can show you that global variable and how the mapping was achieved. The global variable, I called it status result, and the structure, the JSON structure of that complex object type is exactly the same as what is expected as the response back to our client of this service. So very simple to create a global variable. If you haven't done it before, you simply click on there. If you indicate of a type, if it's not a scalar type, but a type of object, then this will open up to give you various data sources. In my particular case, I simply took that get status response, and I was able to use that as the value of the type to create this status result variable. Well, we don't need another one, so I'll close that. And now let's take a look at the stitch action itself. In order to get to the stitch action, we simply dragged and dropped the data stitch into the flow where we needed it, and then once it was there, it opens up this configuration pane. You'll notice that I've actually created 4 assign operations. Each one is going to place into that status result complex variable. The first one is the ID. The second one is the created by. The third one is the date. And the fourth one is the owner. And the value that we're placing into there is the value of each of those in turn from that get status response from that external service. So that's where that data mapping takes place. Okay, so before we do a test, let me show you why we use the scope activity. I wanted to handle fault handling logic within the scope, and so within the default fault handler, notice that I put a note in that I want to handle the error in some case. For now, notice I can use that stitch action again, this time to populate an appropriate error message. So if you'll notice, what I chose to do was to take the status variable, and I want to get the value of that. In this case, I can't get it from the external service that we called, because that call would have failed. So in the fault handler, if the call fails in there, we're going to provide the ID they provided when they sent the request in the first place. In this case, this was the ID that they were curious about. The second one, though, under created by, I just kind of created a simple error message to provide a value for the created by variable for the status result response. And in this case, I simply hard-coded an invalid item ID. Let's return back to the scope, and I'll close that up. And let's go ahead and save this. And then we will close and activate the integration. Once the integration is activated, we can go ahead and do a test. I'll simply click on Run. To open up my test harness, first I will go with an item that I know exists, number 123. We'll run the request, and I get back a response accordingly. Let's do another one that works. 789 works. And I get back the response information for that one. If you'll notice in the activity stream, once it renders, I can see the data stitches that were done along the way as it built from those assignments. I can see the payload as it was building in each step along the way for each of those assign operations. But let's now do a test where I send an invalid item. So that means the call to external service will fail. But rather than returning that fault back to the client, we're going to return them something more interesting, and that is a response that indicates that indeed they have provided an invalid item ID. And notice that we can see the error in our activity stream on invoking that status, but because the fault handler caught it, we're using the stitch action to populate that error message. Now on to the second use case, where I'll use a data stitch append operation within a for each loop to build the full message payload to be returned. Now this use case is a little bit more complicated, so let me first show you the trigger of this one. This has been defined then as a REST request where a client now will send in a payload as a post request. Let's take a look at the payload he'll send in. It's a simple array of IDs. What he's looking for is the information for all these IDs of whether or not those items exist on the back-end system. So to provide that answer for our customer, our client of this integration, the response type that we provided back for him is going to be a result array that will echo back his ID with a value of true or false as to whether or not it exists. Now, that data to be returned back to him, we're going to achieve that by going and making a call inside of a for each loop. And within that loop, if we can look at its configuration real quick, we can see that the repeating element that has been provided is that request wrapper of data that they provided. And within there, we're simply going to say, look, the current item, there'll be multiple items in that array. That's the one we want to iterate on, and we'll call that new data element current item, which is what we have here. Now, let's go ahead and make a call. When we make a call to the external service, we're going to get back an item status, and as you saw in the previous part of the demo, what returns is a lot of various pieces of data as a result of making that call. Let's take a look and remind ourselves. What they're going to return in their response is this JSON structure that indicates all this information. Well, we don't need that information back to the client. We just need to tell them whether or not it exists. So the design of this scenario is to now, within this for each loop, every time we invoke it, if that item exists, we're going to use a stitch action to build the array response. If it doesn't exist, we're going to go into a default error handler to go ahead and use another stitch action to indicate that it doesn't exist. So in order to achieve this, we need now two global variables for this one. And let me show those to you real quickly. One of the global variables is an array that exactly matches the response that he's expecting. The array of exists true or false. The other will be a temporary item. Now, how I built that, let's just kind of take a look, is you do it based upon the object that's involved. In the case of the array, I simply took the response that we need to send back when we define on the trigger, and we simply use that response wrapper result as what needs to be returned. If you recall, that was the array of items, simply dragging that in as the response. For the response item, we simply now build that with a JSON type to define. If we'll take a look at that real quick. Let me close that. And you can see that within the stitch action. So let's go take a look at our stitch action. We'll first look at the one in the fault handler. So what we did is we first define the response item. Again, there's that global variable I created, which is simply going to build one item that's going to then be mapped into this response array. So first, before I append to the array, I need to build the item. And we do that with two operations. One is we assign the ID of the current item, and then we manually populate the value of false. In this case, I used a Boolean function and used the false operation to be able to populate that result. Now that we have that result, we can then take the result. Let me expand this. We can take that response item result and we can now append it to the response item array. We'll do the very same thing within the fault handler. I'm sorry, within the main scope. That was the fault handler, and the very same logic occurs in that stitch action, where here again we are going to add the value of the current item to the response item ID, and we're going to manually populate the true function, or the true Boolean function, to provide a value for the exists, and then use the append operation to then paste that result into the response array. Let's now take a look at that in action. And now that it's activated, let's do a test run. In this case, I need to populate the request with one or more items. I've got 3 items in my test here. When I execute this, for every one that exists, it'll say true. There's my result. And the one that doesn't exist, in this case the 4, 5, 6, it's going to say false. And if you notice really quickly over here in the activity stream, I can see that the for each loop had 3 iterations. One of them failed, which is what we expected. It went into the fault handler. In that case, it was the invocation of the get item status that failed. The fault handler then executed the operations of the stitch append to provide this value here in the middle. But if we look, of course, at the other iterations, like let's open up the third one, we can see that that one was successful. Therefore, the stitch true appends were done to provide the values of the 1, 2, 3 and the 7, 8, 9. And that's it for the data stitch action demo. Thanks for watching.
Welcome to the short video on OIC parallel action. Now, what is the parallel action? Here's the documentation. You can use a parallel action to process tasks in parallel to improve integration performance and response times. So we're splitting the path of our integration, or we're splitting the path of our integration into multiple branches. Typical example would be here, an auto processing integration, individual tasks for checking inventory, customer credit, legal constraints, etc. Now these tasks from a business perspective can be performed in parallel. And of course, when we model it that way and at runtime they're executed that way, we're getting increased performance. So without further ado, let's have a look at a very simple example. So here is my my project. And as you can see, the project is like a folder for all of your integration artifacts, integrations, connections, lookups, libraries. With a project as well, I can have RBAC, resource-based access control, saying who can edit the artifacts in this project, who can view them, who can monitor them, etc., etc. So let's look at the integrations. We have here 2 integrations. Account legal check and account finance check. So these are 2 checks that can be done in parallel. The overarching use case is Salesforce accounts being synced with customers in NetSuite. And before that can be actually done, this parallel checks integration will be called. That'll invoke these 2 guys in branches. So let's go in here. I'm just going to go in. First of all, here's a version of that hasn't the parallel branch implemented. So here, of course, is my trigger. And as we can see in here, the request is a new account, or a couple of fields from that new account. These ones here will be used by legal. The annual revenue, this is interesting for the finance folks. And the response is just going to be the actual status, whether it's approved or rejected, as you can see here. Okay, so I'll just cancel this guy again here. And let's drop in the parallel branch. So I go in here and I can see here, I've got parallel. I just drop it in here. And here we've got our 2 branches. Now, with the branch, we can have up to 5 branches. And when you've reached the 5, you will see that this add is deactivated then. So you can have up to 5 branches. I'll just delete that. At branch level, of course, we can put in a title, so to speak. So I can go in here and just put in a name. Legal check. This is our legal check. As you see, the name appears here. So within this, let's put in the invoke. So I'm going to do a local invoke of that integration. So local legal check. And I see here all of the integrations to which I've access, and there's my legal check here. So I do come. And as I say, I spelled it without the C. And of course, I just go into the mapper and map the required fields. And as you can see, for the legal check, the actual annual revenue is uninteresting. We're just worried about the actual address information here. And there I've got that guy done. So I just validate that. That looks good. And then I can just exit. So that's that check. Of course, we can go to branch number 2. Again, I could give it a title. Let's not waste time though. Let's go in and call that integration, which will be local finance. And this time I do actually use the C. We can see here, there's the finance check, continue, continue. Again, just a case of going in here and actually mapping the fields. And in this case, the annual revenue is interesting. So annual revenue, account name, billing street, city, postal code, and country. So we have all of those fields mapped. Just click on validate. Go over here. And we have everything done there. Now you can see here, I've got a couple of maps already created there, just putting in the result, but let's delete them and so on. So main point to note here is, of course, let's get rid of this guy as well. So we can start off afresh. Here are my two branches. I'm invoking this check here. I'm invoking that check here. Here we have what's known as the join. So the branches join up here again. And of course, this is where I can have my switch. So my switch is just going to check on the status of both of those checks. So I go in here and I can say the first node and I say, let's go in here. And we'll call this guy here, account is valid. Or valid account. Valid account. And here you see there is the request to legal check. There's the response from legal check. And the same, of course, for finance. So I'm interested in the responses, of course. So I'm saying if this guy returned approved, and then I'm going to add another condition. And you can see the default is and. I'm going to make that an or if I wanted to. I go in here to the finance check. Here's the finance response. Take that guy across, equal to, and of course, I'm looking for APP or OVED, approved. Just save that. So here we have a valid account. So I have a variable called vStatus, and I'm just going to update that here to show that it's valid. And I just do here assign approved. And let's go in here. And there it is, my vStatus, and I assign that APP or OVED approved. So of course, the other path, if one of those checks or both checks fail, we've got to do a rejected assign, so to speak. So we just go in here. Assign rejected. And take our variable and set that to rejected. Now, the final map is just mapping the response. So here we go. Map. Pull this guy across, and it is there, the response we're mapping here. And it's vStatus going to status there. Okay, validate and close. So now we've done our parallel branch. We've implemented this. Let's go and save and let's actually test this out. So here we go. I'm activating the integration. You will see here there are 3 levels of tracing. I can set production, audit, debug. Debug is great, of course, for demo purposes, for development, testing, etc. So we leave it at debug. And then the integration is active. So just click run. The payload here, we will see. Annual revenue is good. Annual revenue the financial check will fail if the annual revenue is 0. So when we run this flow, it should come back with status approved, which it does very quickly. We go in here, and now we can actually see the design time at runtime. Both branches have executed. We see here it's a valid account, and we've mapped and we've returned the approved status accordingly. Thank you very much.
Welcome. In this lesson, we'll learn more about using the scope action in your integration flow. The scope action essentially serves as a container for a collection of child actions and invokes, providing the behavior context for those actions. Anything that you can do in the integration's main flow, such as configuring invokes, mappings, and actions, can all be done within a scope container. The elements defined within the container have local visibility inside that scope action. There are two primary reasons for using a scope action. One is that it allows you to organize connection invokes and other actions associated with accessing an external system, but more importantly, and the main reason why you use these, is to provide for scope level fault handling logic. Since I'll be covering scope fault handlers in another lesson, I'll save those details for later. For now, let's focus on the basic implementation. Simply use the inline menu to add the scope action to the design canvas anywhere on the main flow. Then inside the scope container, you add one or more actions and invokes as needed. Here's an example where I've added 3 placeholder note actions just to illustrate. But one of the benefits of using scope containers is that you can make the design canvas look less cluttered after you have many more actions in other scope containers. You simply collapse the scope container by clicking here, and then when you need to look inside or do more editing, you expand the container again by clicking here. Additionally, just like most other actions, you can cut and paste to reposition it to another location in the flow if needed. However, there are some context considerations to keep in mind, since your design logic needs to take into account that any returned data or message received from invoking a service or any new variable created within a scope will not be visible outside the scope or anywhere else in the main flow for that matter. So the most common solution is to create one or more global variables which are scoped to the entire integration instance. Then configure a data stitch or an assign action to append those local variables values or message data values to the global variable. Now, to provide even more capabilities, you can also add additional scope actions or containers nested. Consider them as child containers within a parent scope, which allows you to become more sophisticated with separating actions into subsections of your integration. Each of these child scope containers can have their own local variables, but more importantly, you can also implement specific fault handling logic for each one. And indeed, you can have as many levels of nested child scopes as you wish. However, I would recommend that you avoid making your integration too complex. It might be better to create one or more separate integrations that could be invoked from the parent integration to implement reusable logic that could be used by other integrations. So to wrap up, the scope action is used for better organizing the actions and invokes within your integration flow. But in another video, I'll explore the details about those scope level fault handlers. That's it for this lesson. Thanks for watching.
Okay, this recording is to show the OIC 3 feature for the OCI function invocation. So I'll walk you through what exactly is happening here, and then also show where specifically we've added feature functionality for OCI functions. So let's start. We will first click on create. This is an application or rather application orchestration type of invocation, and we name it as zip files. So very straightforward. We will have a REST trigger. This REST trigger is essentially sort of emulating an invocation from external application. In our case, when we test, it will be the OIC test console. So we just provide the relative resource URL. This is the /zip files action that will be invoked on OIC 3. We will add some parameters and we expect a response to be sent back. So the parameters here are actually coming from the documentation of OCI function. This is a pre-built function. This function takes files from a given bucket and then zips it up and puts it into another folder or another bucket on OCI storage. So these are the parameters for that we need to specify: the compartment ID, the region where this is executing, the source bucket, and the files, the source files. We also specify what is the target bucket and then whether we want to allow overwrites or not. So these are the parameters that we will accept from as part of the invocation to the OIC orchestration. And you will see this later, when we actually execute this. So once we have added all these request parameters, what we're going to do next is, of course, introspect this particular function. But before we do that, we also need to provide response type, and that response type is going to be the output from the OCI function. So this is again well documented, and we are just going to copy paste the target data or the data that we got from the documentation. So we continue. This is our trigger that is done now. So we are now ready to do the actual invocation of the object store. So we add a new action. This is available on the palette. We pick it up from the palette itself, and we just provide it a name as to what we want to call this particular endpoint. So we are going to call this zip files in bucket. We need to point to the region. So in our case, it's US Phoenix 1. And then the compartment is OSW23. This is a demo app that is part of the OCI function creation. And that zip files is the actual function. Now, the OCI function itself requires input and output. So this is the input. Again, this is part of the documentation. So we are just copy pasting the input, that is provided or that is going to be used by the OCI function. So we just copy paste that. And then similarly, the output is again from documentation. Once the function executes, this will contain the response JSON object from the OCI function. So we put that in. So what we saw over here is OIC3 has the the functions capability, where you can provide the function or introspect the function, provide input and output. The next thing that we do is we map the source and the target. Now this is being done for the parameters that the client application will send to OIC integration, right? So whatever data we are collecting from the client application is being mapped over here to the same elements in the functions parameter. So this, once it is done, we will next do the mapping for the response, and that is again going to be very similar. Whatever response comes from the OCI function, we are just going to map it back to the response that the OIC integration, this particular integration, will send back to the client. So we open up the appropriate response data structures or payloads and then do the mapping appropriately. So this is, again, this is dependent on what the function has been coded for, what is the input it takes, which is what we saw earlier, and what's the output that it sends back. Once we have done that, we validate and we go back to our integration. So this is now ready. All we need to do now is to specify or add the business identifier. So in this case, what we are going to do is we are going to open up the query parameters, and we'll take the source bucket and target bucket as the identifiers. This can be anything. There is no hard and fast rule, as you're probably aware. And once we've done that, we can now go ahead and activate this particular integration. So we'll set a debug, since this is just for demo. And then this gets deployed, we can just check the status. So it's active now. We go ahead and click on run. And the OIC test console will come up here. As you can see here, we've already filled all the input parameters that we saw earlier. And this is the OCW23 demo bucket. That's the source. This is the target bucket. The target bucket doesn't have any files at this moment. And we go back to our integration where we've already entered all this data. Source files is /, which will mean take all files from that folder. We are running now this particular integration, so it'll take a little bit of time, but this is now successful. We can see the output that has come from the function. And if we refresh here, we will see that our interaction or integration is completed successfully. We go back to target bucket, which was empty, and now when we refresh it, you will see that it contains a new zip file, which actually contains all the source files from the source bucket. So that's about it. Thanks for watching and listening.
Welcome. In this video, I'll demonstrate how to use one of our newer actions, the OCI Object Storage action. There are two parts to this demo. The first is to create a new sample integration that leverages the action to create a new bucket in OCI Object Storage. And the second scenario will be to create an integration that uses the action to upload a file to be added as an object to that bucket. Let's get started. We'll start by creating an application pattern integration that will be invoked by an external REST client. We'll name this integration bucket create, and then use this REST adapter trigger connection. The endpoint will essentially take in a name for the new bucket. We'll call it bucket create. For the relative resource URI, we'll keep it simple, just /bucket create. And we need to select the post action HTTP method and just choose to add a parameter. In this case, this will be a query parameter, which the client will provide as the new bucket name. We'll call it bname using the string data type. Now, with the trigger configured, we're ready to add the object storage action, where this immediately opens the configuration wizard. Let's call this endpoint bucket creation. The resource type will be to manage buckets, choosing create bucket for the operation, and then select the appropriate OCI compartment. And that's it. We click finish, and the action is complete. Next, we open the newly created map action to load the map editor. And here we need to map that provided query parameter bucket name to the name field. And that's it. We click to validate the mapping. And now we need to define the business identifier for this integration. And of course, it makes sense to use that bucket name for the identifier. With that done, we save the integration, and we can now close it. Let's activate it, selecting to use the debug tracing level, which is useful when we're testing this integration flow. And now that is in an active status, we click Run to open the Testing Client tool. But first, let's view the list of buckets that are already in that compartment. As you can see here, just these three, ERP bucket, HCM bucket, and this one called Scripts. Let's now return to run the integration to create a new one. We'll call it OCW demo bucket, and then click Run. So for this use case, we chose not to provide any JSON response to the client, but as always, we can use the activity stream here to view the message that was processed and see the processing status. Let's head back over to the OCI console and refresh the page, where we can now see the new bucket with that specified name. And when we click on it, we see that it is empty with no objects. This is how easy it is to create buckets using the object storage action. Let's now go back to the OIC console and move on to the next use case, creating another integration that will upload objects to a bucket. We'll call it store file. And once again, use that same REST adapter connection to trigger the integration. We'll name the endpoint store file as well. And we'll use /store file for our relative resource URI. Once again, we select to use the post action, but this time, in addition to adding request parameters, we select to also configure a request payload, which will be the file to be uploaded. So we'll use two query parameters, the bucket name, which bucket to store the file, and a name for the object. Both will be string data types. Now to configure the request itself, where we simply select binary as the request payload format, then click continue. To complete, we click finish. Now with the trigger interface configured, we once again select to add the object storage action. We'll call it upload file, but this time choose to manage objects, then select the upload object operation, and that's it. Click continue, and then click finish. Now to open the map editor, loading the mapper here, where we need to map the stream reference of the file that was provided by the client over to the upload operation, along with the bucket name and the object name to be used for that file. We now validate the mapping and close the map editor. Now we need to define business identifiers for the integration. For this case, in addition to using the bucket name for the primary business identifier, we'll use the object name as another identifier, which is useful later for monitoring. With that completed, we save and then close this configured integration. Let's now activate it, choosing once again the debug tracing level. And once it is activated, we click here to run a test. So here on the test page, we provide the name of an existing bucket, and of course we'll use the name of the one we just created earlier, OCW demo bucket, along with an object name. We'll call it f1.jpg. And then over here in the body pane, we select File, click Choose File, then locate the file we wish to upload. Here it is, the Red Bull Racing Zoom image file. And now click Run to send the request to the integration. Let's refresh here to update the activity stream. And when we expand Invoke upload file, we can see that the message has been processed. Let's now go back to the OCI console to see the bucket. I'll refresh the browser page. And you can now see the newly uploaded object called f1.jpg. And from here, we could choose to download that file to see the image. Well, that's it for this demo. Thanks for watching.